Hey everybody. I know some of you have not had much background in statistics, or it's been a while since you've had any. So I wanted to give you a quick, just kind of overview of some basic concepts that you can use for finishing some of the discussions this week. And I'm going to use the Paint application here on my computer and draw some things to help you understand. So it's not going to be neat, but hopefully it'll help you figure out some of these things. So the main thing that statistics is going to help us do in this class is it's going to help us summarize people's performance on tests. And so the first thing, if we have a whole group of people who've taken a test, one of the first things we can do is just draw how they did on the test. So I'm going to create a line here on which we can draw how people did, and in the middle I'm going to put 100. And over here, I'm going to put 85. Over here, let's say scores are 115. Over here, there's 70. And over here, they're 130. And we could take each person and make them a particular dot on this graph. So if we had, say, 100 people, we could make 100 dots. You probably don't want to watch me do that, but let's say we have 4, 5, 6, 7, 8, 9, 10 people scored 100. We have a few more here who scored 99. We have some here that scored 102. And then as we go out, we have 4, 5, 6 people who scored a 90. We've got 5 people who scored an 85. We've got 7 people here who scored 110. So, etc. You get the idea here. We can just make a mark for each person who took the test and where they scored. Now, if we look at what I've drawn here, and we can draw a single line across the top of all of these, we have here what is basically what we call a normal curve. And all a normal curve means is that it's this general shape where most people score in the middle, and as you get further and further away from the middle, fewer and fewer people scored. And so what that is we see all sorts of things that fall into a normal curve. If you measure the heights of trees, for instance, you'll see that most of them fall somewhere in the middle, and then you have a few on the ends that are very skinny trees and a few at the end that are very big trees, and it's normally distributed. Most cluster in the middle, a few on the ends. If you think about intelligence tests, they're actually usually reported on this scale with a mean of 100. And most people fall in the middle with a mean of 100. You have fewer people out here in the very low and a few people out here in the very high. But this is generally a normal curve. And this curve gives us a lot of ability to be able to tell lots of different things about where people are, and we're going to get to that in a minute. But one thing we will always want to do is just kind of find, well, what's the average score? And when you have a normal curve like this, the average is always going to be in the middle. If you added up all these scores and figured out the average, would the average score be down here? No, of course not. Is it going to be up here? No. It's going to be in the middle where all of these people are. And so our average score is here. And in statistics, we call the average that we get by adding up and dividing, we call that the mean. Okay, so that's pretty clear. But we also might want to know, well, how spread out are these scores? So here's one way they could be spread out, but we might have another distribution, the same numbers, but maybe everyone's really clustered in the middle here. Everyone scores up here in the middle. Again, forgive all my messy marks. All the scores are clustered in here, and there's only a couple people who are scoring out here. And so in this case, we have a very tall and skinny distribution. But its mean is still at the same place. It also has a mean of 100. So how do we describe the difference between this, where people's scores are very spread out, and this, where they're very close together? And that's the concept of standard deviation. One standard deviation tells you how many points there are in between the mean and the given number. And if we know one standard deviation is the amount that about 67% of our people fall in. So to figure it out, they figure out where do 67% of the people fall, and then plus and minus that number is one standard deviation. So here, one standard deviation, we might say, well, we know about 2/3 of our people fall in between 85 and 115. This is plus one standard deviation above the mean, and this is minus one standard deviation. So this is below the mean. So your plus signs, your plus standard deviations are going to be above, and your minus are below, and it really tells you how spread out the scores are. Now down here, plus one standard deviation might be at, let me change to letter here. So our mean's at 100 plus one standard deviation. So another, 60% of our group might just fall right in here at 105. And the other group here might fall into 95. So 95 is minus 1 and plus 1 is 105. And we know that about 2/3 of our people, about 66%, fall between those two scores. So they are much closer together than these scores are. So a standard deviation here is 15 points. A standard deviation here is 5 points. So the bigger your standard deviation, the more spread out your scores are. And by looking at different standard deviations, we can tell how spread out scores are. Now the thing you're going to do this week is calculate something called a z-score. And that tells you for any particular person how far they are away from the mean. But instead of just telling you, so let's say this person scored a 110, we can say, well, they're 10 points away from the mean. Why do we need to figure out a z-score? And if we just wanted to look at this test, that would be fine. But what if you scored a 110 on this test up here and a 110 on this test down here? You might want to know on which test did you do better on compared to your peers. So to figure that out, so remember here we said we have a mean of 100 and a standard deviation of 15. Here we have a mean of 100 and a standard deviation of 5. The formula to figure out how far this given person at 110, how far away are they from the mean, and how far away is this person from the mean, but we want to always do it in standard deviations. How many standard deviations are they away? Because that'll help us compare from one test to another. Otherwise we'd say, oh, they're 10 points away here, they're 10 points away here, they did the same. But compared to their peers, did they do the same? So to figure that out, we have the value, the score minus the mean. So you do that first, score minus the mean, and then you're going to divide by the standard deviation. All right, so for our first example, our score is 110, and the mean is 100. So 110 minus 100. And then we're going to divide that by 15 because that's our standard deviation, right? We define that. So we have 10 divided by 15, and I didn't bring my calculator out here. Our next one is going to be our same score, 110, minus same mean. We had the same mean for the score, but our standard deviation is only 5. So here we have 10 divided by 5, which equals 2. And let's figure out what that other one is there. We've got 10 divided by 15 equals 0.67. Probably could have done that in my head. All right, so this tells you on the first test, your 110 is above the mean because this is a positive number, but it's about 2/3 of a standard deviation above the mean, 0.67 standard deviations. And if you look where it falls between, if this is 0 standard deviations at the mean, because you're at the mean, 0.67 is about 2/3 of the way, right here. So our score of 110 is about 2/3 of a standard deviation above the mean. Now here, 110 is 2 standard deviations above the mean. So your same score is actually compared to your peers, you did better on the second test than on the first test. You were 2 standard deviations above the mean. That means you probably did better than about 97% of the people who took the test. Whereas here, you only did better maybe, so we know that 50% fall below the mean, and you've got another probably, maybe 20%. So maybe you did better than about 70% of the people. Again, you don't need to worry about that number, which is actually an area under the curve figure. But just think about this is these z-scores are numbers where you are looking at how far above the mean is someone. So 0 is going to be at the mean. Anything positive is going to be above the mean, and the higher the number means the more people you did better than, and the lower the number is going to be you're below the mean. You're doing worse than other people are. And finally, the last kind of concept that's brought forward is t-scores. And t-scores are just like z-scores, but sometimes people don't like this idea of negative numbers here because it's hard to figure out how did you get a negative score on a test? You're -1 standard deviation? What does that mean? So a t-score is just like a z-score. So we talked about z-scores, the mean is 0. And you can see that if you subtracted the score minus the mean, 100 minus 100 is 0. Divide by 15, you get 0. So the the mean always has a z-score of 0. And so there's that piece. The t-score just changes all of this so that at the mean, the t-score is 50, and 1 standard deviation is +10 instead of +1, and -10 instead of -1. So it just changes the scale a little bit, and that can be a little bit hard to figure out, but just think about it as mean of 50. Anything above 50 is above the mean, or below 50 is below the mean. And that sometimes people find that's easier to interpret when they're reporting test scores, but sometimes not. So I hope this kind of cleared up some of these ideas for you. Please feel free to contact me and ask questions, and I'm glad to answer. Have a good day.